we have these functions, f of x equals 2x cubed minus 3x plus 1, where x is an element of all real numbers such that x is basically between -1 and 5, and then g of x is 3x minus 2, where the domain is x is an element of all real numbers such that x is between -3 and 3. What we want to do is find the defining equations for each of these and the respective domains for each of the following. Okay, so if we look at the definition from the first page of f plus g of x, we know that that is f of x plus g of x. And f of x is 2x cubed minus 3x plus 1, plus g of x is 3x minus 2. And we just have to simplify this. Actually, maybe technically speaking, I should put them in brackets. And then we just add them together, so we get 2x cubed minus 1. Now, the one tricky thing is, as you saw in the first graph, when we were adding f plus g and f minus g, we had to look at where the domain was common. So here, we'll take a look at the domain of f. And we'll just put the 0 here. And the domain of f goes from -1 to +5. And we know that it's a closed circle because the less than or equal to sign means it's including those points 1 and 5, or -1 and 5, sorry. So that's the domain for f. The domain for g, we'll just draw that underneath here. Leave the 0 where it is, and we know the domain is from -3 to 3. Again, less than or equal to, so it'll be a closed circle. And then f plus g, on the definition before I said that it has to have a common domain. So basically, wherever they overlap, that's going to be the common domain. Okay, so the common domain here is from -1 to 3. Of course, again, closed circles. So that would be the domain for f plus g, and actually it'll also be the domain for g minus f of x and g of f of x. So the common domain here then for all of these is x is an element of all real numbers such that -1 is less than or equal to x less than or equal to 3. Okay, and then the rest of this is just a little bit of algebra. So g minus f is g of x minus f of x. So we have 3x minus 2 minus 2x cubed minus 3x plus 1. And then that gives us -2x cubed plus 6x minus 3. And it'll have the same domain as f plus g of x. Okay, that domain will be the same for all three. And then g times f of x, we know there's 3x minus 2 for f of x. G of x is 2x cubed minus 3x plus 1. Okay, so now I have g of x times f of x. Then we can just expand through this and simplify. So we get 6x to the power 4 minus 4x cubed minus 9x squared plus 9x minus 2. And again, that's under the same domain. Okay. Now moving along, when we just have a set of points, basically you're just going to look for the ordered pairs that share x coordinates, because that would mean that they're on the common domain. So all you have to do is worry about the ones that have the common x-coordinate and just deal with those. Because -1 and 1 are not the same, we don't have to worry about that point at all because they're not on the same domain as each other. So now for f of x, or f plus g, we'll just add the y values. So we get -3, 3, 0, 1, and 2, 3. For f minus g, we get -3, 5, 0, -7, and 2, 7. For g minus f, -3, -5, sorry, -5, 0, 7, and 2, -7. And f times g, -3, -4, 0, -12, and 2, -10. Okay, so that is the lesson for 1.7. That's the last lesson of Unit 1. Here's your assignment for today. Please work on the first few at home and work on the rest when you come into class. And here's the review. You can start working on that. And just notice that the question 17a in the review should be this. Okay, thanks for your attention. See you in class.